Thank you. Now this is the year 2025, and now we can start the reviewing and the revision of the last year's Kcse 2024 physics. So here we'll start with physics paper 1, and therefore we can start off. Feel much welcomed. Then ask a friend to join us, and also don't forget to subscribe, and also make sure that you do share this work. May God bless you as you join me. Thank you so much. Here comes the paper. Therefore, we can start and have some good engagement together. Here is the paper. You can view it. This is section A, which comprises of a maximum of 25 marks. Question 1 is always from measurement 2. From measurement 2. Therefore, you are told that the figure below, it shows a vernier scale of a vernier caliper. Then, now you're told that on the figure include the main scale. Supposed to read the main scale, but they have written the main style. So that the vernier caliper shows in a measurement of 3.15. We can start from somewhere. Therefore, we all know that for us to get the 3.5, we must reverse it first. So we ask ourselves what was supposed to be of the main scale and the vernier scale. Therefore, if we get to have that, then we shall have it well done. Therefore, we can say that if we reverse this one, we are supposed at long last to get 3.15. Therefore, can say the main scale, this one read 3.1, and the vernier scale read 0.05. That we arrive at 3.15 centimeters. Therefore, for us to get 3.15, then we must first draw 3.1, and the 3.1 must be on the left side of the 0 mark of the vernier, that is of the vernier scale with this one. So you can say that is 0. You can say this is 1, 2, 3, 4, 5. So we need, at long last, we have a scale. Therefore, we can go. I'll draw a 3.1 first, where we'll say 3.1 like that. I will say this is now my 3. We have some serious shock. I think I can change. Therefore, now this becomes my 3. Therefore, I need to count so that I make sure that I have at least 1 centimeter. Therefore, I should find where will my 4th centimeter be from. Therefore, I can say this is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, can say 3.7 somewhere here. That is 3.7. And then I have 3.7 at this mark. They should coincide to be somewhat like a straight line. Yes. 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8. Let me just say 3.9. Then my 4th centimeter is at that point. Then because of this coincidence, this part, now you can read it as 3.1 of the main scale. Then from the vernier scale, 1, 2, 3, 4, 5. Then we have 5 times the least count, that is of 0.01. Therefore, we arrive at 0.05. Then this becomes 3.15 centimeters. You are told to explain why weight of an object is a vector quantity. Remember, we should say that weight is given by mass times gravity. Therefore, gravity acts in a specific direction. Gravity acts in a specific direction. Therefore, because of that specified direction due to gravity is the one that leads to making weight to be a vector quantity. Therefore, you can say that weight, which is dependent on force of gravity. And this one acts towards the center of the earth, which always acts towards the center of the earth. So this issue of this force acting towards the center of the earth is the one that will give this one the specification of a direction. We have question 3. And it reads, the figure 2 shows a shape of bimetallic strip made of metals A and B when heated. State the reason why the strip appears as shown. You can see that A as bent inwards. The same applies to B, but which one caused the other one to bend the other way around? So because A is on the outer part, is the one that caused B to bend in that manner. And this variation can only be brought by the difference in linear expansivity, meaning that one metal must expand in a faster manner compared to the other one. Therefore, in this case, we'll say that metal A has a higher linear expansivity than B. Then now we need to explain the shape. This makes it to bend inwards. Makes metal A to bend inwards. We have question 4. It is observed that in order to balance the seesaw, the heavier child sits. Closer to the pivot. State the reason for this observation. The only thing that can result into this one, we have the issue of the effect of a force, the turning effect of a force. Therefore, we must understand the force must be balanced with the distance from the pivot. Therefore, we'll say that the turning effect of a force of a force which is given by force times the perpendicular distance from the pivot, then the heavier child to be balanced the distance should be reduced. Or when carrying a bucket of water. Then here we go. So you see a person leaning on one side, or else he raises the opposite hand. Therefore, those two methods you can say one by leaning on the opposite side. By leaning on the opposite side. Or you can say raising the opposite hand. like that. The diagram below, that is figure 3, it shows a simple sanitizer dispenser. This one. Then you are told to explain how it works. Therefore, we know that, okay, from the diagram, you can see we are having a nozzle. We have a vent, this is like a hole, a small opening. We have the sanitizer here, we have the piston here. Therefore, here we will apply the principle, that is the Bernoulli's principle. So the moment we push this piston inwards, then we are forcing the air inside this barrel to move very fast, short at a higher speed, meaning that it is going to lower the pressure inside. It is going to lower the pressure inside. Then, because we are having a vent here, then high atmospheric pressure will act inwards, forcing the sanitizer to move upwards. Then it will come out through the nozzle. Therefore, you can say the piston, when the piston is pushed, inwards, the air above the tube moves faster. Moves faster. Which we have said it is the opening, allows in higher atmospheric pressure, which acts on the liquid. You can say on the sanitizer because we have a specified liquid acting on the sanitizer, pushing it upwards. Like that. We are having question 7. It shows a mambo that was set into oscillations when it was released in a ball. Therefore, we expect this one to move to, then backwards, like that. Then told on the axis provided, sketch the velocity time graph for the motion of the marble in one complete oscillation. Only in one complete oscillation. Therefore, we should not add anything else because the question is specific. The question is specific. Only one complete oscillation. Therefore, if you look at a complete oscillation, it moved from the top part of this side to the top of the other side and then went back. That is what we call complete oscillation. Therefore, we have several ways in which you can draw one. You can use this one. We say we choose a specific amplitude like that. Then I have a certain point here, like that. Then I will say that it began all the way from 0 like that. Moved now to the center. And then it went back to the 0 mark. Now you have understood the reason why I drew some dotted lines there is to make sure that we have equal amplitudes. Or else, you can use the normal one, the one that we are used from the books. Like that. That is a complete oscillation. Now we can proceed. State the meaning of viscosity as used in fluids. The meaning of viscosity is used in fluids. Therefore, this is the friction or resistance. Is the friction or resistance to motion in fluids. That is what we call the viscosity, just the friction that occurs in fluids. A machine raises 20 kilograms through a distance of 0. When an effort of 100 is moved through, determine the velocity ratio. Velocity ratio is given by the effort distance you divide through by the load distance. And our effort distance we have 0.32 divided by 0.2, and this one we get at 1.6. That becomes the velocity ratio. A gas bubble is released at the bottom of a pond containing water. It is observed that the bubble rises to the water surface. It expands. Then you are told, explain this observation. We know that pressure increases with depth, and therefore, when the bubble is at the bottom, it is very small because of the higher pressure at the bottom of that fluid. But as it comes towards the surface, since the pressure is decreasing due to decrease in height, then it is going to increase in volume. That is why we say it is increasing in the size. Therefore, we'll say that as the Bible rises up, the pressure due to water column, a stone of mass 200 grams is tied at the end of a string that is 1 meter long. It is wound in a horizontal circle at an angular velocity of 10 radians per second. And you are to determine the centripetal force. So, in this case, we can analyze the question. We have a mass of 200 grams, which is 0.2 kg. We have a radius of 1 meter. Then we have the angular velocity of 10 rads. Then, how do we get the centripetal force? Fc is given by mass omega squared r. Therefore, we'll have a mass of 0.2. We have the omega, which is the angular velocity, that is 10 squared, times a radius of 1. Therefore, in this case, we shall get this 100 times 0.2. Therefore, our Fc is equals to 20 newtons. An object is released into a eureka can full of water. It is observed that the weight of the displaced water is equal to the weight of the object. Then you're told to explain this observation. Then this is as a result of the law of flotation, where we can say an object displaces its own weight. It displaces its own weight. Therefore, it is going to displace a liquid that is having the same mass or weight as of that object in which it floats. In liquid. So you can say this is supposed to be off the liquid. Of liquid in which it floats. This is the law of flotation. A student observed that smoke particles in a smoke cell move randomly. State what causes this motion. And number two, what will happen to the motion of the particles if the temperature in the cell is increased? So what causes this motion of the particles is that, remember that we have invisible air particles that are in a random motion. Then they are the ones that will cause this motion. Therefore, you can say it is a collision of smoke particles with invisible air particles which are in random motion. Which are in continuous random motion. I think now we can change the pen. What happens to the motion of the particles if the temperature in the cell is increased? In this case, we expect to have an increase in kinetic energy, which at long last will keep the particles have an increased movement. Therefore, the rate of collision increases due to increased kinetic energy. Due to increased kinetic energy. Now we have the section B, which is of 50. Therefore, then this is the ratio of density of a substance to set areas of application of relative density in our day-to-day life. We have several of them used to determine the density of unknown substances. Number two, we have the test of purity. Of substances. And in this case, we have milk, which is highly tested. It is used to check the states of charge in a car battery, among others. You can also add use in brewery companies to check on alcohol content. A student blew air into a balloon, tied it up, and released it into the air. It floated for some time, but slowly descended to the ground and settled. Explain why the balloon settled on the ground. So at first, you can say the weight of the balloon is greater than the weight rest. Therefore, this in turn will bring about a small impact of upthrust. Hence, experience a small upthrust. A small upthrust. So, at what time did it start descending? It descended slowly when the weight of the balloon and its content get reduced below Tanya Kido. Nimekuona. State two ways in which the balloon could be meant. The ways the balloon could be meant to keep floating in the air. We have several ways in which you can maintain it in the air. We have one, we fill the balloon with air of low density. Of low density, e.g. helium. We have decrease the volume of the balloon by heating or warming up. A hollow metallic cube of 1,000 cubic centimeters is submerged is submerged in a liquid of density 1,100 kilograms per cubic meters. Then you are told determine the upthrust acting on it, given that G is 10 newtons per kg. Upthrust will be given by volume times density times gravity. Therefore, the volume here is 1,000 cubic centimeters. This will be equivalent to, you convert it into SI units, that is 1,000. You multiply by 10 raised to power negative 6. Then you multiply by a density of 1,100, 10 times 10. In this case, you'll arrive at 11 newtons. You'll arrive at 11 newtons. We have a small disruption, but no problem. We can proceed to the next part. That is question 15. During an experiment to verify a certain law, a student was provided with some masses, a spring, and a meter. Then you are told state the law the student wanted to verify. You have some masses, spring, and a meter. What did this student wish to have to verify? Therefore, the moment you are told state the law, you have two options. Number one, you give the name of the law, or number two, you state the law the way it's supposed to be stated in a statement form. Therefore, the law which is required here becomes the Hooke's law, becomes the Hooke's law. And you understand that this one says that for a helical spring or any elastic material, the extension is directly proportional to the force acting, provided that the elastic limit is not reached. So you have that other method of writing it. States one other apparatus the student needed in order to carry out the experiment. So where were you going to place the mass? Not the mass, but where are you going to place the meter rule? You can only put it in a stance, or you can say a clamp, or that is clamp goes with the bob and bob, like that. Explain the measurements taken during the experiment, how they are used to verify the law mentioned above. So you must get that law so that now you can understand. Therefore, this is what you can do. Record the force. This is due to masses and the extension cost. Then plot a graph of force against extension. If it leads to a straight line through the origin, then it verifies the law. Like this. We can proceed. A load of 0.04 newtons causes an extension of 0.4 centimeters on a certain spring. Determine the load will cause an extension of 0.6 centimeters on the same spring. First thing we are supposed to calculate or determine the spring constant. Therefore, we'll say that the spring constant is given by force over extension. And in this case, we are having a force of 0.04 newtons and an extension of 0.4 centimeters. Therefore, this becomes 0.04 newtons. And this one, you convert it into a SI unit. This will become 0.004, like that. Then this will give us 10 newtons per meter. Then now using the Kcse tool, now when we are having an extension of 0.6 centimeters, now we are asked what load will it be. Therefore, we'll say that since we have the spring constant as 10 newtons per meter, then our extension is 0.6 centimeters, which is equivalent to 0.0606 centimeters. Then we want the force. Therefore, force is given by Ke, like that. Therefore, our spring constant is 10 times 0.006 meters. This will give us a force of 0.06 newtons. That manner. As students, provided with a piece of wire and asked to make a spring. After coiling the wire on the rod, the spring appeared as shown. Then you are asked, you can see the appearance. Say two ways in which the student can modify the spring to make it stiffer. In short, to make it strong. Therefore, how can you make a strong spring? We have several methods, and they appear as of now. So using a thinner rod to coil the wire. Use a thinner rod to coil the wire, to coil the spring. Coil the wire ends. So the moment you use a small rod, we will reduce the diameter. Hence, reduce the diameter of the spring. So it's like saying reducing the diameter of the spring will make it strong. Another one, we have using shorter piece of wire to have shorter spring. Using a shorter piece of wire using a shorter piece of wire to have shorter spring. To have shorter spring. And this in turn can say Moskid. Temekona. Thank you. Thank you for joining me live. Have shorter spring. And this one can say you reduce the length of the spring. Can reduce the length of the spring. Therefore, all these ones are as a result of the spring was already there. And since the same wire was used, then what changes could have been made so that the stiffness could change or else could be increased. You can see I'm running out of power. But we can try. We have some few questions covered. Therefore, in our question 16, the setup is showing a ticker timer and can be used to determine acceleration due to gravity. It's just a form of ticker timer. You can see the way it is. Then now, describe how the setup may be used to determine the acceleration. Then you are being awarded 4 marks. Therefore, you must be very careful in the way to do it. Then switch the timer and release the ball. Free. Get the time between. Loss from the frequency. Timer. Then determine the initial and the final velocities. So this one is V, this one is U. Then use the formula of getting acceleration that is given by V minus U over total timetable. Then this one to determine the acceleration. A stone of mass 0.2 kg tied at the end of a spring is wound in a vertical circle of radius 10 meters. 1 meter. Determine the minimum velocity required for the stone to maintain a circular motion. Therefore, in this case, we shall use the formula of centripetal force and the relationship to weight. Therefore, we can say that centripetal force equals to weight of the stone. Therefore, we say Fc, which is centripetal force, can be given by mv squared over r, and it's also the same as the weight of the stone, mass times gravity. So we let these ones stay off the equation. Therefore, we can say, since ordinary mass constant, then we cancel out. Therefore, we remain with v squared over r is equals to g. Then, how do we make v the substitute formula? Then, v will be the same as the square root of rg. Therefore, the radius here was 1 times 10. Then the square root, we arrive at 3.162 meters per second. That becomes the minimum speed. Or you can go the other way around, the long method, where you need to calculate what is the Fc in the Formula 1, this one, and in this one. Then whatever is in question, you make it the subject of the formula when you have the figures. State 2 applications of centripetal force. It is used in separation of mixes. Using centrifuges. It's also used in banking. Use it in banking trucks. Used in construction of speed governance. Allow me finish that. We shall give a continuation of question 17 and the last question. This is due to issues of power shortage.